Hi, in this video I'm going to show you how to use NTAG 210 and NTAG 212 using my box. If you Google for NTAG 210 or 212, you get the PDF document which I'm showing here. The reason why these two tags are described in the same document is structurally and functionally both these tags are identical. The only difference is the memory capacity. So 210 has got 48 bytes of user memory, whereas 212 has got 128 bytes of user memory. So I'm going to explain in detail how to use 210, and whatever you learn for 210 is the same for 212 as well. So both NTAG 210 and 212 are manufactured by NXP Semiconductors, and I'm going to point out some of the important sections in this document which are useful to use these tags. So if you go to page number 3, you can see some of the important features of these two tags. So as you can see here, it has got 80 or 164 bytes organized in 20 or 41 pages. So the 80 bytes refers to 210 and 20 pages refers to 210. Likewise, 164 bytes and 41 pages refers to tag 212. Out of these, only 48 bytes or 128 bytes are freely available, and it has got the 4 bytes the capability container, and it has got the static locking for the first 16 pages. So this applies for NTAG 210, and because NTAG 212 has got more memory, we also have the dynamic locking to lock page numbers more than 16. One of the interesting bit here is you can protect the read and write access by means of a password, and it also has got some kind of a originality check, so you can verify whether any given tag is actually manufactured by the NXP or not. If you go to page number 5, there also you find information about the memory capacity, about the number of bytes reserved and number of bytes for read and write. Next, we jump to page number 10. This is the most important page for us. So here you see the memory structure of NTAG 210 and 212. So on the top table is for NTAG 210 and the bottom one is for 212. So as you can see here, NTAG 210 structure is similar to NTAG 203 as well. The page 0, page 1, page 2 are reserved. This consists of the static locks as well as the serial number, and page 3 is the CC or the capability container, which has got some initial data returned during manufacturing. It is because NTAG 210 is NFC Forum Type 2 compatible. So after that you have the user memory. This is where we can read and write, and the last 4 pages in case of 210 it's 16, 17, 18 and 19. So that's an hex, but sorry, that's the number 16, 17, 18, 19. You have again reserved pages which carries configuration, password and other things which I'm going to explain how they work. So when you scroll down and look at the structure of NTAG 212, it's very identical except you got a bigger user memory, and totally you got 41 pages, and because there are more pages you need a dynamic locking, which is very similar to what we saw in NTAG 203. So before I show how to read and write or use the password, I would like to point out two important features which are introduced in NTAG 21X is if you go to the NTAG commands and click on the get version. So this command returns some information about the tag itself. For example, if you can see here, that command returns you 8 bytes of information which is decoded as seen here. So which for us, we are more interested in the byte number 7, that is the storage size, which as you can see here for NTAG 210 it is 0B and for NTAG 212 it is 0E. There is information about how to decode this 0B 0E which is explained here, which is not very important for us, so I shall not explain anything about that. The other thing is, if you go to the commands again and click on the read signature, so we have seen there is a feature called the originality check. So this is a new command introduced in these tags. So this command returns you a 32 bytes of information which is, according to NXP, it's a encrypted result of the entire UID, which we can decode using the public key, and we can, using that you can verify whether the NXP tag is from the original NXP manufacturer or it is something different. So I have just started the desktop application and I'm going to click on the connect. As you can see here, the box is connected to COM49. I'm going to place a new NTAG 210 tag and click on the select. So as you can see here, it has got a 7-byte UID, and because we know it is NTAG 210, you have to choose the tab, the NTAG 210. So this is where you work with all the tags starting from 210, 212, 213, 215 and 216. The first thing you have to do is click on the go. So because it's NTAG 210, you can see that you have got around 20 pages, and this grid shows you the page address in hex and the page address in decimal, and these are the 4 bytes of the page B0 to B3, and this column shows you whether the page is locked or not, and this column shows you whether the page requires a password authentication for read and write, and the last column indicates what kind of page is that. For example, you can see that it is a UID is stored here, and the third page is a reserved log bits, and the fourth page is a OTP. If you scroll down, as we saw in the memory organization document, the last 4 bytes are also a kind of a reserved bytes where we store the configuration in these 2 pages. The password is stored in the page number 18 and the pack is stored in page number 19. So I've got 4 tabs, sub-tabs here. This is where you see that the OTP, and you can use this top section to write to a page, and below that you can use it for write to a more than 1 pages. And the next tab is called password and configuration. So this is where you can play with the configuration of the card, and this section is the password section. This is where you can use to change the password or authenticate before you read and write, and the pack is where you can set the pack. The next tab is called logs tab. Here you see that you can change the static locking, the locking that corresponds to the first 16 pages, and below that you got dynamic locking. Some of the sections are grayed out because they don't apply for the particular tag. For example, the dynamic locking applies only for NTAG 212, so that's the reason why it's locked. The last tab is the version and signature. This is the two important feature I discussed about. What you see here is the information we get by using the command called get version, and as we saw in the document, for NTAG 210 the value is 0B, and this is how the 32 byte ECC signature looks like, and we can use this and the public key from NXP, and you can get back the UID, which I've not done it, so I'm not going to speak anything more than this. So this is the structure of NXP 210. So let's see how to read, write and understand the configuration and password. So next I'm going to show you the NTAG 212 tag. I placed one there and click on a select and go to the last tab and click on the go. So we know that NTAG 210 and 212 are identical in structure. So if you scroll down, you can see that you have got around 41 pages, whereas the last 4 pages are reserved, which has got the configuration and the password in the pack, and just above that we have got the dynamic locking page, and this is where you control the locking of the pages more than 16. If you click on the version and signature, so as you can see here, according to documentation, the value of the storage size is 03, and this time you have got a completely different 32 byte signature. So I forgot to mention one more important feature of NTAG 21X, and that's called the UID mirroring. If you go to this page number 3 under features and benefits, so there is a mention about UID ASCII mirror for automatic serialization NDEF messages, and if you go to the page number 17, there is a clear definition about how the UID ASCII mirror works with an example, which I'm going to show you when we start looking at read and write. So let us start play with the NTAG 21X cards. So I'm going to work on NTAG 210, click on a select and go to the last tab and click on a go. So this fetches all the information, plus it also executes the command to retrieve the version and the ECC. So to do a simple read and write, you are going to use the write to page sections. So if I want to change the page number 5 or page number 4, click on that page, and as you can see here, the page 4 data is visible. I'm going to set that to ABCD, click OK and say write, and you can see it's returned to page number 4. If you click on ASCII mode, you can see it's in ASCII mode or hex mode. So likewise to page number 5, I can directly write here. I can just go and write some hex number I want, say 1011, say 34 and 79, and write. So you can see it's written here. You can also write some numbers. Say I'm going to choose page number 6. This time click on DEC. DEC stands for decimal. You can type any 30-bit number. I would like to type a number like this, so which is converted to the hex on the screen. So click on a write. So it's written to page number 6. You can also do some bulk writing. Assume that I want to change the values of the page 10 to 15. So I can use these sections here, change this from to 10 and this, and the data you want to write you can type in here, or you can use these shortcuts for X. Say I'm going to write ABBA and click on write. So as you can see here, from page number 10 to 15 you got the hex. So go to ASCII mode. So you see it's written. So to write, you can use these two sections, and if you want to change the value of the OTP, it's a capability container, you choose that and you can see the current policy of OTP, and you can set the bit you want and you can write it. Say for example, if you want to If I want to write 1 in this bit, make this 1 and write, and that gets written here. So that is how you play with the write, read and the OTP.